All right, so here we are starting chapter 1. This is our first lesson. It's the 0 lesson, so it's actually the prerequisite knowledge. So let's just go through a couple things that you should know already coming into chapter 1. So our very first note, what is a ratio? A ratio is a comparison of two quantities using division. So you'll see this definition show up again later on, but this is what I was hoping we would pick up on. Keywords here are comparison and division. The next question asks, rate each ratio in fraction form, simplify. So we are going to start with this first one. This is colon form. This is if you have a quantity and then a colon, then another quantity. It's a ratio. It's not a user-friendly ratio, so we prefer to write things in fraction form. But we would read it the same way, students to chaperones. Students to chaperones. So what that means is the students go on top, which is 96. And the number of chaperones goes on the bottom. That's 24. So that ratio, first of all, I know you're not happy with the fact that it's an improper fraction. Remember, that's okay with ratios because ratios are always comparing two numbers. So we need a top value and a bottom value. It is okay that the top is bigger than the denominator. Okay, so I know that's tough for us, but don't worry, it's fine. What we do have to do is simplify out the common factors. So I can actually divide 96 and 24 both by 24. And I get 4, 2, 1. Again, I know you're not happy with that. I know you want to hide the 1. Don't. If it is a ratio, we need to have two values. We need to have two values. We'd be comparing two different quantities. So there's my final answer for students to chaperones. Next is the to form, where we write the word to between the two quantities that we're comparing. Again, it's read exactly how I just read it. Students to tickets. So students go on top again, 96. And tickets is 120. So the ratio of students to tickets is 90 to 120, 96 to 120. Again, I can divide by 24. And it's okay if you didn't see the 24 right away. If you wanted to start by, dividing by 2 and then dividing by 2 again, maybe divide by a 3. Keep going until you get it simplified. But I already solved this problem, so I knew what to expect. 96 divided by 24 is 4, and 120 divided by 24 is 5. So my simplified ratio here of students to tickets is 4 to 5. We don't read this as 4/5. We read it as 4 to 5 because they represent different parts. Different parts. Our last example here, number 3, this is fraction form or ratio form. This is our preferred method because it's easiest to do math with this method. This is the ratio of tickets to people. And tickets is our top number this time. That's 120. And people, well, students and chaperones are both people, so we would have to add those two numbers together. 96 plus 24 is 120. Okay, and we know we can divide both of those by 120, and we get the simplified ratio of 1 to 1. I know you're tempted to write that as the whole number 1. Please don't. Please leave that as the ratio form of 1 to 1, which means there is one ticket for every person. Okay, last couple examples here. Determine if the ratios are equivalent. Remember, equivalent ratios are ratios that when they're simplified, they equal the same thing. I'll show you two different methods to prove if ratios are equivalent. So the first one is 15 smelt for every 5 seals. So that would be 15 over 5, 15 to 5, and 18 to 6. So those are our two ratios here, 18 to 6 and 15 to 5. Oops, I miscopied that one there. 15 to 5 and 18 to 6. All right, so one way we can do this, remember equivalent ratios, they simplify to be equal. They simplify to the same ratio. So I can simplify my ratios and see what I get. I can simplify 15 to 5 by dividing by 5. And I get 3 to 1. So my simplified ratio would be 3 smelt for every 1 seal. Let's see if I get the same thing here. I can divide 18 and 6 both by 6 to simplify my ratio, and I get 3 to 1. So this asks for an explanation. I'm going to say my explanation because I'm running out of space here, but I would say yes, these ratios are equivalent because they both simplify to the same ratio, which is 3 to 1. Another way to do this would be to, and I'm going to change colors here, would be to write my ratios and check the cross products. So we can try that method as well. Number 5 says 27 out of 30 math teachers agree. So my first ratio here is 27 out of 30, 27 to 30. My second ratio is 46 out of 50 math teachers agree. So I can write that ratio as well, which is 46 to 50. And I could do the same thing I did in example 4 where I simplify them both and see if they're equal, or I can test the cross products. So that means I can multiply diagonally to see if those products are the same. So 46 times 30, I am going to do a life hack here and use my calculator. Let's see. 46 times 30 is 1,380. And 50 times 27, I think that's 1,350, but I'll check. Yep, 1,350. So my cross products are not the same, so my ratios are not proportional. I'm sorry, not equivalent. Wrong word there. You'll hear that word later on in the chapter. Okay, so if I were going to explain this, I would say, no, the ratios are not equivalent because the cross products are not equal. If you want a little extra practice, try solving number 4 by using cross products. See if you get the same answer. Try solving number 5 using the simplify method. See if you get the same answer. I'll give you a hint. You should get yes no matter which method you use for number 4. You should get no no matter which method you use for number 5. Okay, there's our baseline for ratios. Let's get started on chapter 1.